Hello everybody and welcome to my game engine tour. I started this project in the middle of the summer when I stumbled across some game engine series, and I thought, oh, this is cool, I should give it a shot. As a kid, I was really into making games. I started on Scratch, I made a lot of stuff on Scratch, and then I tried to move on to more commercial game engines like the big boy stuff like Unity, Construct 2, RPG Maker. But I didn't go super deep into them because I just didn't have that much time anymore, and I took a break from game development altogether. But now I'm back, and in the end, I think I still liked Scratch the most because it's super simple and super flexible. So as I was making my game engine, I thought back to a lot of things I did on Scratch, some things that I found tedious, and how I could support it or make it a bit easier in my game engine. Just two disclaimers. Number one is that I don't intend for this to be of the caliber of a commercial game engine. If I wanted something production quality, I would have just used a commercial game engine and it would have taken a lot less time. Number two is that I didn't invent anything in here. I actually referenced a lot of material online. Shout out to all of the amazing resources. Bob Nystrom's book, the Chernal's game engine series. One Lone Coder had a pixel game engine and he made a lot of videos on that I watched. Also Pizzi's articles on basically if you want to make a game engine, you gotta do this, and this. So all of that was super helpful. Just like shout out to all the material online. I did not invent anything. I referenced a lot of material, and I am doing all of this just for learning purposes. So if you're a professional and you have some corrections or suggestions that you would like to point out, I think I would learn a lot from you, and I would really appreciate it if you respectfully shared them with me. So, without further ado, thank you so much, and let's begin. So, number one, data layout. How do we represent our game objects in memory? Spoiler alert, we use ECS. Before we go into ECS, let's start with a strawman implementation. So, let's start with the strawman approach of object-oriented programming. So, say that you have the game objects player, NPC, enemy, fog, and snowflake. And you have an animal kingdom for how you're organizing these objects. So, for starters, everything is an object. Seems reasonable enough. Under object, we have a renderable object. So, this renderable thing might contain things like texture, like what graphic do we display to the player? Position, where do we display the graphic? Okay, so reasonable enough. Under renderable, we might, distinguish between objects that you can touch, objects that you don't touch. So between collidables, that would be player, NPC, and enemy, or stuff that you don't touch, like particles, like fog and snowflake. All of this, seems reasonable enough. We can work with this. But problem one, what if you want to add an object that you can touch, but you can't see? So say you're adding an invisible wall, and you do want it to be collidable, but you don't necessarily want it to be renderable. You could add your invisible wall under collidable as an invisible wall, but then it would have this redundant attribute texture that you don't really use. And you could just ignore texture. You could put a transparent image for texture. But what if, in addition to renderable, collidable inherited from a lot of other random stuff? So now your invisible wall has a lot of redundant attributes that it doesn't end up using. And then you would have to think about, oh, how do I rearrange this so that, I don't have that much redundant stuff? So that's travesty one. Travesty number two is, what if I say I want to add a new property, but I only want player and fog to have this property. I don't want NPC, enemy, or snowflake to have this. How would we approach this? We could add it in renderable, but what if the attribute we're adding has nothing to do with renderable? So you're like, okay, let's add it here, right? And then have renderable inherit from it so that player and fog get this new attribute. But then everybody would get this attribute, right? and then an NPC, enemy, and snowflake would all get this new attribute that you are adding in, when you only intended for player and fog to have it. Like, you see how, like, it gets kind of messy, and you're like, okay, what if I add it over here, and then I only have fog and player inherit from it. But then you also have to be kind of careful of how you name things in this new attribute you add to make sure that it doesn't collide with renderable that player and fog both inherit from. Basically, like, there's just like a lot of mess that comes with this, and as your hierarchy gets more and more complicated, it gets harder to keep track of in your head. Okay, so that's like one problem with object-oriented programming. Another issue is, well, not exactly an issue, but say that all of the objects in your game are falling down, and you're like, okay, so I need to update the positions of all of my objects so that they're falling down. Say that C represents, say that these are objects in your game. Say that C is the position of your object. So you're like, okay, I have to go through all of the objects that have a position stored in them, and I will update their positions. As you can see, as you update the C's aren't next to each other in memory, which is kind of bad because the cache likes it when things are next to each other. So it would be nicer if you stored all of the positions together, like this. Basically stored each attributes together, so that when you update the positions, you just go to the pool of positions and just update the positions. So that is kind of the motivation for ECS. I cleaned up the object-oriented diagram so we can talk about ECS. The issue with object-oriented is basically that we didn't separate the object from the attribute. As you can see, the game objects player, NPC, enemy, fog, and snowflake are all part of the object-oriented hierarchy, as are their attributes, right? Controllable, collidable, renderable. They're all part of the hierarchy. We didn't separate them. So the main idea behind ECS is, let's separate the game objects from their attributes. So we'll take the game objects, player, NPC, enemy, fog, and snowflake. Let's call them entities. And then whatever attributes they have, let's call them components. So let's scroll over to the right. As you can see, entities are very stripped bare. Okay, so an entity is basically just an integer ID. The meat and potatoes happen in the components. The components store the actual data of basically what is going on with this entity. So, for example, say we're adding a player entity. We're like, okay, this is renderable, so we will give it a texture and a position. It's also collidable, so let's also give it a collider component. Now, when we go to add the invisible wall, we can be like, okay, I want this to be collidable but not renderable. So we're like, since it's not renderable, it does not have a texture component. Since it's collidable, let's give it a collider and a position. See how simple it is? In contrast to with object-oriented programming, we had to think about, oh crap, like if we put it under collidable, it's going to have this extra texture attribute that we don't actually use. But in ECS, we can just give it the components that it needs, and we don't have to worry about it having redundant attributes. And we also don't have to think about where it falls in the hierarchy. Likewise, when we want to add a new attribute, or more like add a new component, all we have to do is create a new component pool and then ... So say we want to add like something that only player and fog has, we can just add it here. All right, give player one of them, give fog another one of them, and nice and clean, right? We also don't have to think about, oh, like where in the hierarchy should we add it so that it's like most convenient for us. We don't have to think about any of that. It's a lot simpler to do it this way. Secondly, note that all of the components are stored together in their own pool. So when it comes to, say, like, oh, let's update the positions of all objects, we can just walk through the pool and update the positions. Or we're like, oh, let's do some animation. We can just walk through the pool and do the updates. And since all of the components are stored together in their own pool, it's really, really cache friendly, and it's just structured really nicely. So that's the crux of ECS. So now that you know how data is stored, you might be wondering, how is data updated? That is where the system part of entity component system comes in. So, system. Basically, a system is something that updates the components of an entity. So you can have something like a rendering system for handling animations and graphics. The rendering system will say, okay, I am interested in entities that have these components, and then for every step of the game, it will take all the entities it cares about, basically entities that have a texture and a position, render it to the screen, and bada boom. You could also have something like a collision system, where it's like, okay, I care about entities that have a collider component in position. And then for every step of the game, it would take all of the entities it cares about, update its positions and whatever, check for collisions, do what it needs to do. Basically, a system is something that takes entities and then modifies their components according to some logic for every step of the game. So now you know who updates the entities, but you might be wondering, when does it get updated? So now we can zoom out a bit and talk about the game loop. Okay, so as a programmer using a game engine, what you would do is first you would create all of your entities, like all of the game objects in your game. You would add the components to your entities. You would add the systems that update these entities to your game, and then the game loop would start. For every iteration of a game loop, basically you have a period of time where you check for player input. So this would be like keyboard presses or mouse clicks, okay? And then based on player input and on events in a game, you would update the game state. This is where all of the systems that you added to your game would call their own update function to update the components in your game. This is also where if events happen, like certain like player keyboard events, or maybe some collision events or some transition event happens in your game, this is where those events would also get handled and updated. We'll talk about event handling a bit later though. But basically, like, all the internal state gets updated here. And then we move on to rendering, where basically the changes get rendered on a screen so that the player sees. And then you might have a little bit of delay or a little bit of synchronization, and then it repeats forever ad infinitum. And that is basically a game loop. There's a bit more about event handling that I could talk about, but I think since we have done a lot of talking, we could do some demos. Originally, I thought of listing out every component and system that I implemented, but I feel like that would be kind of boring to watch and also boring for me to talk about, so I like the idea of demos a lot more. I have 3 demos prepared today: a movement, collision, and dialogue demo. I don't really have an agenda for each demo. It's more that if something comes up that I would like to mention, I will mention it. So without further ado, I shall begin with the movement demo. I had the collision demo up earlier, so I will load the movement demo. Alright, make run. Right off the bat, you see that we have a player character. The player character has some nice animations. I took the sprite sheet from the sprite maker for RPG Maker. So as you can see, the design is really ubiquitous. This is a pretty common design that you see for characters in RPG Maker games. And what else? Oh, so I have it so that you can identify costumes and animations by name, so that has been really convenient for development. Another thing to note is it responds to keyboard input, so when I press arrow keys, it changes directions as desired. That's about it for the player character. Other noteworthy thing to talk about is the background. The background is basically an experiment for tile maps. So it was generated from 2 files. One file contains the graphics for what each tile should look like. The other file contains basically like a specification of how do we paint the tiles on a screen. Like what type of tile do we put for each tile. I did the tile map mainly as an experiment to try to get it so that I could have entities share components. For example, as you can see with the sand tiles, each tile on the screen is a separate entity. And then all of the sand tiles share the same component. All of the wall tiles, by the way, you can walk on it, share the same component. All of the rock tiles share the same component, so on and so forth. The tile map is just like an experiment to make sure that entities can share components. So if I overwrite anything in the sprite component for sand, for example, all of the sand tiles would change their graphic accordingly. Alright, I think that's all I have to say for the movement demo. So I'm going to move on to the collision demo. Okay, so for collision, basically I have a collider component. And what the collider component is, it's basically a box for the entity. And then whoever else's collider intersects with this box means that I've collided with this entity. It makes a lot more sense if I actually play the demo. So I'm gonna play the demo, make run. Let me just show the boxes. So the red boxes are the colliders, they touch, kaboom. That's basically the collision demo, nothing much else to say about it. Oh, one thing though, I originally wanted to play sound as well, like the Sasuke Naruto thing, but sound has a bit of clipping, so sound I still have to work on in a later update. Alright, next demo is the dialogue demo. Before I talk a bit more about dialogue, I think I'll talk a bit more about how I used to make dialogue boxes and like the dialogue system in the past. What was kind of tedious or not so convenient about it, and then how I decided to approach it for my game engine. So I'm going to pull up one of my older Scratch projects. Let me stop this real quick. Basically, I lifted this dialogue system from one of my older Scratch projects. It was a game that was in the drafts that I never really published. I made it around my 3rd anniversary of Scratch. Basically, the game was called Scrap Metal, and my vision for the game was that it would be a platformer puzzle game where you play as a circular robot. Pictured over here, isn't he cute? And you're basically a ball of metal, right? You can't really do much except roll around. But as you progress through the levels, you collect more and more pieces of scrap metal, and then the boy is supposed to build new parts for you so that you unlock new mechanics and you can do more stuff, and then you go through some more challenging levels. I didn't really get around to finishing the game. The most I got done was the dialogue system and some cutscenes, and some like basic levels. So yeah, I still like the concept a lot, and it's a game that I sometimes think about revisiting. But anyways, tangent aside, I'm here to just talk about the dialogue system. So I lifted the dialogue system from my old draft of Scrap Metal, and then I can demonstrate it for a bit. So, green flag. As you can see, you can click to advance dialogue, the facial expressions change. And oh, what I really liked about this though was that the portrait lights up based on who is talking. I thought this looked super fancy at the time. I was super proud of this. But yes, anyways, this is the dialogue system. And just for a look at how I did it, like what was inconvenient about it. Basically, I had 3 sprites. I had a dialogue box, the right dialogue portrait, and the left dialogue portrait. Dialogue box, I can show you how I did it. One not so convenient thing about Scratch is that there isn't really a way to programmatically generate text, or like programmatically generate text that looks nice. So the way I did it originally was basically for a dialogue box, I have a box, right? And the dialogue, what it says on the tin, dialogue box. And I would basically copy paste the costume, change the speaker name, change the text, Control C, Control V, change the speaker name, change the text. This is okay if you don't have a lot of lines of dialogue, but when dialogue gets to be really, really long, sometimes I've reached like hundreds of costumes, and then when you reach that point, it starts to get really laggy, and it's also really hard to find things. So that's one inconvenient thing about the way I did it in Scratch. The other thing was the facial expressions. So the way I approached it was I kept a counter for where in the dialogue I was, and then based on that, I would case on where the counter was and change the expression based on the counter. The whole time that I was doing this, I was thinking, oh, if only I could just read everything from a file. It would be so much simpler, so much shorter, and I wouldn't have to do all of this casework. So that was kind of my motivation for approaching the dialogue system again 8 years later. So for the dialogue system in my game, the way I did it was I load everything from a JSON file. This is a pretty simple JSON file, so it just stores basically what gets said. So for each dialogue item, I have the speaker name, what the speaker says, and the facial expressions of the people in the conversation. This is really nice. So far, it's super simple. But later on, it's like, if I want to add animations or sound effects, I can also put it in the file. No fuss, no fuss. And at a glance, I can see how the conversation plays out without having to slog through all of these blocks. Just a quick demo. Oh yeah, I should change level first. So dialogue demo, make run. Okay, so I drew these up really quick. So, it doesn't have the animations that the Scratch dialogue has, but basically, like, I'm happy with how the dialogue system turned out, and I think this will be like 10 times more convenient now that I can read things from a file. So those are my 3 demos. Alright. Okay, so now that you've seen the 3 demos, we can talk a little bit more about the event handling system. You've seen it implicitly in the 3 demos that there was some event handling going on, like with key events, or like with the collisions, or with dialogue advancement. So now we are gonna go a little bit more into how it's done. So I'm gonna go back to the diagram of the game loop and also pull up the other diagram. Be right back. For our event handling system, we basically have a table of events. For each event, we keep track of who cares about that event, basically who's listening in on that event, so that when the event happens, we go through the list of listeners and we call their callback functions. In addition to calling their callback function, we might want to convey some more information about the event to the listeners. So to do this, we pass in parameters to the callback functions. So for example, for the key pressed event, that could be what symbol got pressed, how long did it get pressed for, things like that. For collision event, it could be, who collided with who. Scratch has a similar event system. I think they call it broadcast messages, broadcast blocks. But one small difference, at least based on what I remember from Scratch, was that it was just one string for the message name. So I don't think they had, you could pass in extra parameters. So, for example, if you have something like a hug event, and you have 3 people, Larry, Curly, and Mo, you would have had to create one separate message for Larry hugs Mo, Mo hugs Larry, Larry hugs Curly, Curly hugs Larry, all 6 combinations. But here you can just have one event, a hug event, and then just pass in the 2 parameters. And so it's really nice to just have it so that you pass in parameters for events. That's all I have to say about the event handling and the table that you do. So now we can talk a bit about basically when do we trigger the events, or like when do we check for event triggers and things like that. So all of that happens in the update portion of the game loop. So recall that we said that during the update game step, that's when all of the systems take the entities they care about and update their components. So one detail that I skipped over was that before that happens, we add the systems, or we add whoever cares about what event as listeners to events that they care about. So we add the listeners to the table, and then after that, as the systems update the entities, sometimes they might come across an event, and then they will trigger the event, so like they'll broadcast the event. So say like the collision system detects a collision. The collision system will be like, hey, like a collision happened. And then we would call the callback function of everybody who cares about collision events, and they will go do their own thing. A little caveat, or like a little thing to note, is that the order in which the systems update their components matters. So for example, if you have like a trigger system that cares about collision events, then whether or not your collision system updates before the trigger system really affects what results you get. Like if you update the collision system before the trigger system, or if you update the trigger system before a collision system. Bob Nystrom's book talks a bit more about this, like what order you do the updates in the game loop matters a lot. I'm not going to rehash everything that he said in that chapter, but that's just like one interesting thing that I remember reading about. But okay, anyways, TLDR, that's like the event handling system. I'm gonna go back and do one more demo. So one last demo is level transitions. All of the demos you saw earlier today, I basically organized them into separate levels. I call them levels, but they're more like different scenes of the game. And I think this is another nice thing I like about this, because it's a lot easier to stay organized when you keep each separate scene in a separate file. So it's like, oh, I'm gonna clear the stage. It's the new level, I'm gonna add new entities, new fresh start, that sort of thing. So like it's a lot easier when you've organized everything by level. It makes it a lot easier to just like instantly load a level, instantly debug. Yeah, so I also created a level management system. It's kind of scuffed right now. I might change these into enums later on, but basically this is a level management system that listens in on when it should change the level, and then it loads the new level as desired. So as a final demo, I'm just gonna do a level transition demo. So at the end of the dialogue level, I'm gonna broadcast a message and be like, gotta change to the collision level. And then when Naruto and Sasuke collide, I'm gonna do another broadcast so that it loads the movement demo. So I'm gonna chain the 3 levels together to see like how smoothly we can transition between scenes for our game engine. So I'm just gonna comment this out so that it broadcasts collision level. I'm gonna comment this out so that it broadcasts the movement level. Okay, alright, now we're gonna make... Okay, that took a while, so I was like, alright, anyways, make run. Alright, boop, 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 and it's the collision level, woohoo! Now they collide, and it's the movement level. Yep, so successful, like we are able to transition between levels as desired. That's basically all I have for my game engine tour and my demos for today. I am really proud of the progress made so far, and now it's like I can get started on making my game. As for my game, I might just like make a separate video for that, because I'm still brainstorming what exactly I want to make.
And I've been doing some case studies, haha, case studies. It's like my excuse for playing games. So that I can get some inspiration for making my own game. If I have enough time, I will probably do another update, but I can't really make promises on how fast I make progress, so just stay tuned. And thank you so much for watching.